All right, so we're going to continue on with what we had been talking about yesterday. We're still going to be adding and subtracting these rational expressions. And we're going to focus more on the ones that we needed to get common denominators. Because yesterday we saw a little bit of both, where you had some that already had common denominators, and you added and subtracted right away. And then we had other ones that we had to somehow manipulate one of the fractions to get it to look like the other one. There's going to be cases today where you only have to multiply one of the fractions by something like we did yesterday, but there will be some where you have to multiply both fractions by pieces in order to get them to have common denominators. So remember, in order for us to find the common denominator or the least common denominator, because you want to work with the smallest piece that you can, you want to prevent yourself from having to do a whole bunch of work if you're using really, really large denominators. You factor all of the denominators that they give you, and then you see what's missing. Like, what do they each need to have so that you can multiply with the appropriate thing to the right side of the problem to get them to match. For example, this first one here, we have 7 over x minus 3 plus 4 over x squared minus 9. There's not a lot for us to do with that first set, but the second one here where it says x squared minus 9, we need to factor that a little bit. And we did talk about this case yesterday. This is that difference of two squares that I showed you guys yesterday. So I'm going to leave 7 over that x minus 3 alone. For the second one, though, to factor the bottom, go ahead and draw 2 sets of parentheses. Each one is going to get an x, because that's going to split the x squared. Then you think about what's the square root of 9? Good. So one's going to be positive 3, one's going to be negative 3. So they're always going to have one with a plus sign, one with a minus sign. So now looking at our denominators, we have an x minus 3 on the left side, and then we have an x plus 3 and an x minus 3 on the right side. I have to make sure that all my pieces match. So what's missing is on the left side, I need an x plus 3. I don't need to do anything to the second one, because the second one already has an x minus 3. And if I multiply the first fraction by an x plus 3, then my denominators will match. So I'm just going to take that first fraction, 7 over x minus 3, times x plus 3. And I'm going to do that in the top and in the bottom, just like you would if it was a regular fraction with just plain numbers. And again, I'm just writing down the second fraction. I'm not going to do anything to that one. So for this, like we saw yesterday, we have to distribute that 7. Make sure that you multiply it to both terms over here. So it says 7x plus a 21. And now it's over x minus 3, x plus 3. Or if you put x plus 3, x minus 3, it doesn't really matter. They're the same pieces. And then we still have plus that 4. I'm going to go ahead and switch this one around just so that it matches. X minus 3, x plus 3. Now that I have common denominators, we simplify the top. So I don't do anything to the bottom. We leave that alone. On the top here, we have 7x. There's no x on the second fraction, so I'm not going to do anything to my 7x. And then I have positive 21 plus 4. So 21 plus 4 would be 25. At this point, I would check and see, is there anything that I could pull out of the top, like that I could factor out, to see if I could get either an x minus 3 or an x plus 3 if I wanted to try to do any reducing, which in this case there's not. 7 and 25 don't have anything in common. 7's a prime number and it can't go into 25, so you can't even pull that one out. So I'm going to leave it right here. Okay, so let's take a look at the second one here, number 2. We have x minus 20 all over x squared minus 4x, and then plus x over x minus 4. Looking at the first fraction, it says x squared minus 4x. What is something that I could factor out of that? Just from the x squared minus 4x, what's something that they have in common? X. And if I take an x out, what's left? Good, x minus 4. So that first fraction is really x minus 20 over x times x minus 4. Now the second fraction has an x minus 4. What is the second fraction missing that the first denominator has? Good, x on the outside. So what should we multiply the second fraction by? X. And you want to do it to the top and to the bottom. Don't do anything to the first fraction. So leave x minus 20 over x times x minus 4. Leave that one as is, but take that second fraction times an x on the top and an x on the bottom. So what is my new fraction going to say on the right side? Just on the top, because now my bottom is going to look the same. What's good? X squared. Okay, now that I have common denominators, we can add. What's my new top going to say if I add those terms together? Good, x squared plus x minus 20. And I would keep it in descending order like that. Okay, so put the x squared first, and then your x, and then your number, so that it looks like a regular polynomial. Now I'm going to try to see if I can factor the top there. This is an easy factoring case because it's just x squared, so I should be able to split it perfectly, x and x. But what I need now are those two magic numbers. They have to do two things here. They need to multiply to a negative 20, and they have to add to a positive 1. 5 and negative 4. So x plus 5, x minus 4 is how the top is going to factor. And then on the bottom I have x times x minus 4 still. Is there anything that we can reduce here? Good, x minus 4s. And so I'm going to be left with x plus 5 on top over an x. Now here's a mistake that I would see a student do. They would try to get rid of the x's. Okay? You can't do that because this is really x over x plus 5 over x if I wanted to split it. So yes, you could rewrite this as like 1 plus 5 over x. But what I would see students do by mistake is they would cross off the x's and they would just write 5. So you have to make sure that you think of it, it's each term is being divided by that x. It's not just x being divided by x. You can't just get rid of it on one side and expect it to drop from the other. It doesn't balance out, and then you don't have the same expression anymore. Okay, so make sure that you don't make that mistake. And I don't need to see it separated out like that. If you want to leave it x plus 5 over x, that's fine. I just wanted to show you guys what that actually means. Okay, number 3 here. Let's factor the denominators first. So we have x or m plus 3 on the first one, and then we have m squared plus 8m plus 15. Which denominator needs to be factored, the first one or the second one? Second one, because it says m squared plus 8m plus 15. There's nothing I can do with m plus 3. I can't take anything out. So let's try to factor this just like we were factoring up above. What are two numbers that multiply to 15 and add to an 8? So it factors to m plus 5 m plus 3. So what is my common denominator going to have to be? What do both fractions need in the bottom? M plus 5. And they already both have an m plus 3. Okay, so the first one doesn't have m plus 5, so you have to take that first one times m plus 5. Okay, if you want, go ahead and take a second here, try to finish out this problem, and see what you get for an answer. Okay, so after I multiply, I should have had 2m plus 10 on the top there, and then plus that 9. They're both over m plus 5, m plus 3. What's the final answer say for this one? Good. And again, I'm not going to be picky if you have the bottom switched, so if you put m plus 3 first and then m plus 5, that doesn't matter. It makes no difference to me the order that they're in. As long as the correct pieces are there, that's all that I'm going to be looking for, is that you have the correct pieces in the top and the correct pieces in the bottom. Okay, let's turn the page over here. Okay, so on those last couple of problems, we only had to multiply one of the fractions by something in order to get them to have common denominators. Looking at this case here, where I have 3 over an a plus 2, and then an 8 over an a minus 5, both of them are different, the denominators, and they don't have anything shared. Like the first one doesn't have an a minus 5, and the second one doesn't have an a plus 2. So for this case, we are going to have to multiply both of the fractions by the missing piece. For that first one, the 3 over a plus 2, you're going to have to multiply that one by an a minus 5. Because that's what's in the denominator of the second fraction. And then that second fraction, that one says 8 over a minus 5. What do I need to multiply this one by? A plus 2, because I need that piece from the first fraction. So in this situation, I have to do both fractions times the missing piece in order to get them to match. So for that first fraction now, remember on the top you're going to need to distribute your 3. So it says 3a minus 15. And now I have a plus 2, a minus 5. For the second fraction, distribute the 8. So 8 times a and 8 times 2. So that's going to say 8a plus 16. And again, now this is over a plus 2, a minus 5. Okay, so again, now I have common denominators, so we should be able to simplify the tops by kind of adding pieces together here. What is my top going to say when I combine like terms? What would be 3a plus 8a? Good, 11a, and then you're going to have plus 1, because negative 15 plus 16 is going to be positive 1. Okay, and there's nothing we can do there. I can't factor anything out of the top, because 11 and 1 are only going to have a 1 in common. And I don't want to do that. It's just, it would be a wasted step. So you leave your answer here. Okay, let's take a look at number 5. What do you guys think your first step should be? Factor the middle one? So I've got an a in both. What are my two numbers that multiply to a negative 12 and add to a positive 1? Good. Positive 4, negative 3. Okay, so I want you to think to yourself for just a minute. The first fraction is over a minus 3. The middle fraction is over a plus 4, a minus 3. And the last fraction is over a plus 4. You don't have to change all the fractions, but you do have to change a couple of them. So I want you to think to yourself, what would I be doing here? Can you tell me which fractions need extra things? First and third one. What does the first one need? Good. The first one needs a plus 4. The middle one needs nothing. Okay, so don't do anything to that middle fraction. Just leave it as 7 over, I'm going to go ahead and switch it around, a minus 3, a plus 4. What do we need to do to that second, or I'm sorry, the third fraction? Good, it needs an a minus 3, so multiply by an a minus 3. Okay, I want you guys to take a couple minutes, finish this up, multiply, and then try to simplify if you can. Okay, so here's what they look like after I multiplied. Now don't try to do any crossing off of things on your fractions right now, because if you do that, you're not going to be able to add them anymore, because then you're going to no longer have common denominators. So make sure that you combine the numerators first, and then see if there's anything that we can simplify. So I'm not going to do anything to the bottom, so I'm just going to say a minus 3, a plus 4. On top, you have 2a plus 8 plus 7 plus a minus 3. So let's combine our a's first. 2a and an a would be 3a. What's going to be 8 plus 7 minus 3? 12. So we have 3a plus 12 on top. On the top there, is there anything that I could factor out? 3. So I'm going to take this one step further. If I factor out a 3 from the top, what's left? Good, a plus 4. And then this is all over a minus 3, a plus 4. What can you guys do next? Good, cross out the a plus 4, and I'm left with 3 over a minus 3. Okay, I'm going to give you guys 3 to 5 minutes, depending on how long we need, to do this whole problem by yourself. look at that first fraction, we see that they have a d in common on the bottom, that if I factor that out, it says d minus 2. So the second fraction has a d. So they both have a d here. What's the second fraction missing, though? What is the second fraction missing? Good, the d minus 2. So I'm not going to do anything to my first fraction. But for that second one, we're going to have to multiply by a d minus 2. Now when you do that on the second one here, on the top, you will have to FOIL this. You have to do your first, your outside, your inside, your last. You guys did that a couple chapters ago with those multiplying polynomials. So the first fraction is going to stay the same. The second fraction now, if I FOIL, is going to say d squared. Outside is going to be a negative 2d, and inside is going to be a negative 4d. So that's negative 6d if I combine them. And then last, negative 4, negative 2 is positive 8. This is over. Oh, I'm going to write it out on the bottom as a factored form. D times d minus 2. Okay, so then if we simplify on the top, where we're subtracting, so d squared minus d squared, those are going to basically cancel each other out. Now a negative or minus of a negative 6d, that's going to change that to positive 6d. And then 3 minus 8 is going to be negative 5. Just watch your signs on that one there. And that's all over d minus 2.